Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to be going over a problem in which you're given the starting conditions or starting materials of your reactants, but you're only given one product, the amount of one product formed, and you're asked to find the equilibrium constant. So let's get into this. Okay, so in this problem, we're asked to determine the Kc if 6.0 moles of A added to 6.0 moles of B in a 2-liter flask yields 0.10 moles of D at equilibrium. Okay, so the first thing we want to do is, since we're given the moles, we want to get that into concentration, because when we solve this problem, we have to use an ice table, and when we use ice tables, it's got to be in terms of concentration. So they're giving us 6 moles of each of A and B. So let's go ahead and convert that to molar. They've given us 2 liters of volume, so to find molarity, it's moles over liters. So we're going to take the moles of our A, right? That's going to be 6 moles of A divided by the 2.0 liters, and that's going to give us a concentration of 3.0 molar for A, right? So, but the concentration or the number of moles of B that we start with is exactly the same, so the concentration of B will be the same as well. So the concentration of A to start with, right, initially is going to be equal to the concentration of B initially, and both of those are going to be equal to 3.0 molar. Okay, so now we can kind of set up our ice table. So we've got ICE. So the initial amounts we said for A is 3.0 molar, same for B, 3.0 molar. And we're initially starting with 0 amounts of C and D. Now, normally we would try to figure out what X is and what the change is, and and then figure out what the terms of E or the equilibrium concentrations in terms of X. But they gave us a piece of information that's going to be helpful. They said that these amount of moles of A and B yields 0.10 moles of D. So we have gone from 0 moles of D to 1 or 0.1 moles. Now again, we have to put that in terms of concentration. So we should take the 0.1 moles of D, and again divide that by 2.0 liters, and then that's going to give us a concentration of 0.05 molar for D. So we're going from 0 concentration to a concentration of 0.05, right? So because of that, we can actually figure out what X is, right? So here, the change of D is 0.05. That means we added 0.05 to get there. So now we can relate this change in D to the other changes in C, B, and A by the stoichiometric amounts, by their coefficients. So this is a 1:3 ratio. So if I gain 0.05 here, then I'm going to gain 3 times as much here. So all I have to do is multiply 0.05 by 3, and I get 0.15 here. So I'm gaining 0.15 here. So go 0 to, if I'm adding that to 0 to start with, then I end up with 0.15 molar here at equilibrium. And so again, this is molar. And so here this is a 1-to-1, so if I gained 0.05 here as a product, then I'm going to lose 0.05 here as a reactant. So I'm losing 0.05 here, which means that if I lose 0.05, then this is going to become 2.95 molar at equilibrium. And again, if this is 1-to-2 ratio, 1-to-2, so if I gain a 0.05 amount there, then I'm going to lose double that amount. So I'm going to lose 0.10 here. So this is going to end up becoming 2.90 molar at equilibrium. Okay, and so now we can plug this into our equilibrium expression for K. So the expression is going to be Kc is equal to, and we're going to have the concentration of products raised to their stoichiometric coefficients over the concentration of the reactants raised to their coefficient, stoichiometric coefficients. So here we're going to have the concentration of C raised to the power of 3. Let me make that bigger. Multiplied by the concentration of D raised to the power of 1. We don't write ones. Now I'm going to have the reactants on the bottom. So here I'm going to have the concentration of A raised to the power of 2. And then I'm going to have B, again, the concentration of B raised to the power of 1. And so now I can put in the amounts here at equilibrium. So here I'm going to have C. C is 0.15. So 0.15 cubed multiplied by the concentration of D, which is 0.05, divided by the concentration of A squared. A is 2.90. That's squared. And then I'm going to divide by the concentration of B, which is 2.95. And then when I put that in my calculator, I get 6.801 times 10 to the, where'd it go? -6. And of course, if I round that, I got sig figs here, right? So if I'm subtracting, I can limit this to 2 sig figs here. So that would be 6.8 times 10 to the -6 for my K value. And so that is how you solve this sort of problem when you're given starting amount of your reactants, but you're given one of the product amounts that was created, and so you can fill in your ice table accordingly. So I hope this was helpful. If you enjoyed this video, if you like this video, if this helped you in any way, then please go ahead and like the video, hit that like button, share the video. Also, subscribe to my channel, help me out. Hit that notification bell when you do. Click all so you can be notified by all of the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me, and have a great day.